it was above 40 degrees in Kolkata, and feeling under the weather, I was a bit late for the seminar and hurriedly reached the venue in Tower 1, first floor of our TCG CREST in Bengal Eco Intelligent Park in Salt Lake, Sector 5, Kolkata. Many people are unaware of this gem standing in the heart of Kolkata, in which I will be taking you today. First of all, we were welcomed by Professor Bhanu Pratap Das and Mr. Swapna Bhattacharya, followed by here we are having a talk by Professor Arun Kumar Pati on Planck's constant to quantum computing and mechanism. Although it was more than 40 degrees outside, here inside we are sitting in the cooler temperature of 20 degrees Celsius. And as you can see, the room in which we are sitting is the seminar room, which is absolutely beautiful and has all the essential amenities that we require to attend the seminar. And soon we are having a short break, a tea break, and I have spotted this amazing coffee machine and having a latte. Moreover, we are having some sugar bags, tea bags to help us, and cookies. And very soon, here is my second cup of latte. As you can see, this is the premises of the Secure in TCG CREST, and I will be taking you to more places here in TCG CREST and the lab tour as well. And now I have taken this cup of milk with me to go in the seminar. Here comes Professor Bhupendra Nath Dev, who will be taking us to a beautiful presentation from quantum computing to Heisenberg hypothesis, superposition, wave particle, etc. And friends, here you can see that the class cubicle we are having here, the students who are pursuing their PhD have been preparing their thesis. Not only the students from physics background are welcome, but as well as students from communication and computer science IT departments. Here we are at the end of the seminar, and after that we will be having the lab tour and everything. Now a short video is being shown by the Secure on their work. Moving on to the break. Now let's take a small washroom break. After that we will be having the high tea as well as some snacks. So moving on to the premises of TCG CREST and navigating through the classrooms. Here you can see how beautiful and clean the premises is. And now everyone is getting some snacks accompanied by some tea, espresso latte or whatever that you want. You can get from the small coffee machine over here. And allude by that, let's have a cup of latte again. So guys, just now I had a talk with one of the professors, and very soon our tour of TCG CREST is going to start, and we will be able to see the quantum lab, the atomic lab, and here our tour starts. So you can see that how big the premises of TCG CREST really is, and the labs are very spacious. It has been spread into a vast area. Going through all the classrooms and everything, moving towards the lab. Here we are on the way to our first lab, and we are having very two helpful seniors students. and they are helping us to understand how this machine works and how they are using quantum computing and other mechanisms to get their input and desired outputs. The level of work that they are doing here in TCG CREST is truly unmatchable. And now we are heading to the second lab where Abhishek sir will help us to understand how his project and thesis are going on the atomic models and other researches. Moreover, let me tell you that this lab is maintained at the temperature of 14 degrees Celsius. So while outside it was above 40, inside some students were shivering, literally shivering, and I was so cold.
Okay, my name is Abhishek Bhardwaj, and I'm a PhD student here. I'm currently in my second year. So what we are working on here is quantum sensors. Yeah. Okay. Oh, don't try to understand. You won't. I just keep explaining. You can refer to that picture or this picture. So this is the point we'll trap the lasers. Okay. This point at the center. How we'll trap it? We'll send lasers from all directions. Plus minus x, plus minus y, plus minus z. Now you will think like that might actually push the atoms, right? Like if I put shine laser on an atom, that will actually push it, right? You might have read about something like radiation pressure or something. So when atom absorbs a photon, it gets pushed. So that is not cooling it down. That is basically giving it energy, right? That's not what happens actually. So, you know, atoms have like fixed energy levels. If the photon matches energy, then only what do you call it? Stimulated absorption. Yes. Then only that happens. Otherwise, the atom doesn't see light at all. Okay. So that is the thing we'll use here to trap the atom. Okay. So we'll use specific frequency of light so that it traps at the center. Oh god. You didn't get anything. Yes. You got it? Okay. Oh, you had to do that. Okay. Come over there. Come over there. A beam. So what that beam does is splits the atom into two groups. Okay. So the rubidium atom has one ground state, one excited state. You see the red ones? These are the excited ones. So excited ones means they absorb the
why rubidium?
And guys, here we are almost at the end of our tour.
Okay. How do I expand this?
So as you can see that hardly there are any other people except us. So let's head out. It's almost closing time. It's almost around 7:30 or 8. Some glimpses of today's day. And here we are waiting for the lift. So today was the day, a day in TCG CREST Kolkata, where they are offering various kind of PhD programs, and they have collaborations with a lot of foreign countries as well as with a lot of national institutions, with the government of India. And you can see that it's quite dark outside. We have spent the whole day here, and at the morning I was in such a rush I couldn't show you how this actually particularly beautiful it looks. And in the night time you can see all the lightnings here, all the lightnings that is done. This is the morning view of the same place. And this place is situated in Kolkata at Salt Lake, the Bengal Eco Intelligent Park. And here I am on the way to my team. I need to just catch a bus. the catching a bus in Salt Lake. And this side is horrendous anti-air conductor thingy that the bus is empty even if the passengers are literally hanging outside the gates.